Well, hello and welcome back again. Now, today I'm going to be delving into a subject in very basic arithmetic. I was going to say mathematics, we'll call it arithmetic, but it is mathematics, of course, as well. One that sort of drives the internet mad, and it's a subject that has been kind of driving me crazy as well, because I've tried to explain to so many people. I think a lot of them teachers at schools and maybe in the United States who follow rules blindly without any sort of care and attention and perhaps any deep understanding. And this is that problem that you've all seen, which is the one where you have a division. That's the one here. I'll just show you. There are similar ones all over the internet. 6 divided by 2 times 1 plus 2. I mean, this is pretty trivial for professional engineers, of course. What's the answer to that? Most of us professionals would look at that and say, well, you've got 2 plus 1 is 3. You do the brackets first, multiply it by 2, that's 6. And then 6 divided by 6, and the answer is 1. And that would be it. Of course, this divide symbol we hardly ever see at all, and yet it still appears in social media all over the place. I've always thought it's really obsolete. If I can find the little bit of information, apparently in this book by Kajori, History of Mathematics, back in 1923, is 100 years ago, he was suggesting that this divide symbol, the one we see on our calculators, also another one which is just the colon is sometimes used. It's got no real meaning anymore, and we should be using the slash symbol. It's just the one I'm going to be using, of course, if I do it at all, and drop the symbol. And of course, this has happened. I mean, I don't think you'll see any published papers using this old-fashioned divide symbol. So that's my first comment, is we shouldn't even be using that. Even if you were programming in C or any other language, you wouldn't be using that, would not be part of the syntax of the language. So let's go back to this problem. Even the celebrities have jumped in on this one. Carol Vorderman, she's well known from a while back on a TV show where she did very fast mental arithmetic. She's, I think, originally a civil engineer as her background. I'm not sure if she worked much in civil engineer, but there's no doubt she's got a very quick way of calculating arithmetic in her head. So, and she says the answer must be 1. Of course, that doesn't mean it has to be 1. So why is it that there are so many people around saying the answer isn't 1, but the answer is 9? Well, it's something that I don't think I would have studied at school at all, this sort of thing. I think it's more of perhaps maybe at American schools, I don't know, maybe they do now in UK schools. But we didn't tend to have things like this, expressions like this with numbers in them. We'd have algebraic expressions, but when we wrote them, they were without ambiguity. So the important thing about mathematics is it has to be written without ambiguity. So life isn't about solving problems given to you by a teacher, which is what teachers think. It's about communicating information to other people, in terms of mathematics anyway. So if I was to tell somebody, here's something, just work that out for me, immediately I run into a problem as to how they're going to interpret my result. So I'll come to back to this in a minute, but what most people would do, of course, is they'd see the 2 and the 1 and they'd say, well, we're not going to argue about that. That's 3 there, and we've got 6 divided by 2 times 3. And most people would say that's 6 divided by 6 and that's equal to 1. But no, not if you're trained in a primary school in the United States or somewhere like that. They would say, no, that's not how you do it. And indeed, if I was to type this into a lot of calculators, I would get an answer of 9. Okay. So this is why you would get an answer of 9. is because there's a sort of convention, but it's not a universal convention. It's not like it's fundamental to mathematics in any way. That the divide and multiplication, we've got a multiplication here, though it's not written in there, 2 times 3 is there. Yeah, there's a division and a multiplication. Which one should we take first? Which is the priority? And the sort of unwritten convention is to go everything from left to right. So which would mean that you would have 6 divided by 2, which is 3, multiplied by 3. You get an answer of 9. And indeed, if you were to type something like this into MATLAB, you would in fact get 9. Okay, so you've got to ask yourself what's going on here. Why is there this ambiguity? If we write it in fractional form, assuming that this is how it should be, we don't have a problem at all. And that's why, of course, in professional journals and engineering and science, we never come across this, because we write everything in an unambiguous way. So there's a thing here about mathematical idioms, which was written by a mathematician, again, about 100 years ago, Lenz. And he says here, if I can sort of expand it a bit, that if you take 9a squared divided by 3a, you would expect that to be 9a squared divided by all of 3a, that is. And that you get an answer of 3a. But if you use the left to right method, which is proposed in many schools, you get 9a squared divided by 3. So there's a division there and a multiplication. So left to right, you get 3a squared, and then multiply by a, so you get 3a cubed. And you're saying, well, no, that's not the way to go about it. Now, it's not that is wrong and the other one's right. It's a matter of interpretation. But what do we really mean by that? This is the book I was mentioning, another one about notation, which is a good one to read. History of Mathematical Notations by Kajori. Another interesting website, and this is a PDF of a lot of that, is by Oliver Knill from Harvard, who goes over this about the ambiguity that's caused in schools over multiplication, division, and so on. And here's the similar, I think it's the same problem. The math equation that tried to stump the internet. He's got some equations at the back. Again, that's our Kajori book, which is a good one. And he's basically saying the same thing as I'm going to say in a minute. We've got the 9a squared divided by 3a is equal to 3 and not equal to 3a cubed. So, and the next part of this talk, I'm just going to go into a little more detail about how to overcome this. So here's the problem again, written down in the old format, but I'm going to write it as 6 divided by 2. I suppose I should put times 1 plus 2. If you put that into a C program or any kind of software, you'd be doing, if y was the output, you'd be doing something like y equals 6 divided by 2 would be like times something like 1 plus 2, and then you'd output the answer to the screen or wherever you're putting it. And I suppose this is why it's kind of dangerous, and it's useful to know it's not just for primary school children, that if you were to write something like that, you're in danger of getting the wrong answer, because here what's going to happen is the computer's going to go left to right, the compiler rather, although I guess it depends on the compiler, but most compilers will do things this way nowadays. As I say, it's a kind of unwritten convention. So you get, what it'll do is it'll do 6 divided by 2 and it'll give you 3, and then it'll multiply by the 1 plus 2 it'll take within the brackets, that'll be 3, and it'll give you an answer of 9. And again, you're left with, oh, is that what I intended? So it's really about communication. And if you're an engineer and you give a formula to somebody, if you said y equals, now what was that problem? Something like this, 3a squared divided by 3a. So if you wrote 3a squared over 3a and said, work that one out, most people would take the 3a to be like that, and you'd get an answer of a. Okay, but again, if you were to write that in a computer language, you'd write 3 times a. Now, depending on the syntax,
is in Mandarin Chinese.
Sorry about that. Let's suppose that was for squared. Okay, whatever notation syntax is used, and then it would be divided by 3 times a, and it would work that out as 3 times a squared. Well, you define a equals something before, of course. It would work out 3 times a squared. It would then divide by 3, so the 3's would cancel, so it would give you a squared. And then it would multiply by a, and it would give you an answer of a cubed, which may not be what you're after again. So I think all I want to say in this video is the answer to this is not to write things in an ambiguous way. So if you wanted to divide those two, that problem, 3a squared over, you would write 3a squared over 3a cubed, 3a, was it 3a? 3a. Okay, and obviously that's equal to a. It's not equal to a cubed as well. You can assume juxtaposition where these are together all the time, and most people would, but it doesn't mean that everybody will assume that, and certainly computer syntax will take things usually from left to right, as I've just explained. And if you are writing an expression and giving it to somebody and say, solve this, so if I say to somebody, here's y equals, say, 3 AB divided by C D, I said, here you go, that's the formula for whatever happens to be. Again, I'm on dangerous grounds writing like that, because if somebody is come up through the primary schools, certain areas, they'll say, okay, that's equal to 3AB over C multiplied by D, which is perhaps not what I wanted. So what I'd have to say is that's equal to 3AB divided by, and then put CD there, however ugly it may look. If I wanted the other answer, then I'd have to write it as 3A, and that would be, let's say B over C would be one way to do it, times D, or I would write it as 3AD over times B over C. And again, there would be no ambiguity there at all. People will say, well, why do you write it? Why not just write everything as a fraction? And I think that would be my solution to it, is to write everything as a fraction, and you never this problem just disappears overnight. Teachers don't like that, because in primary school, children, of course, haven't necessarily studied fractions. They may do division, but they don't understand. It's far. So if you did 6 divided by 3 to a primary school child, he might not know that's 6 over 3. But he may be able to, he or she may be able to do the division anyway, but without understanding fractions. I know that when I was at school, I don't think fractions came later, so that's probably the reason why they do that. I don't know if there's anything else to add. So this is about communications really more than anything else. If you're talking to somebody and you give them communications in English and say, do this, then do that, and do the next thing, the clearer that you are in your communications means that the person will be able to follow what you do. If you say anything that's ambiguous, you can expect a mistake. That could be a very big mistake, of course, in some cases. So there's nothing to be proud of, really, to say that oh, I do everything left to right, so that's the way of it. It's not really about how you feel, the answer, what the answer should be. It's really about how you communicate that to other people. And in the case of software, you must make sure that you put, if you want it to be divided by CD, that you write the brackets in all the time. And people will come and say, brackets is not necessary to solve this problem. I mean, I've had this 100 times. People with the original problem, they'll say, oh, no, you don't need brackets. There's only one answer, and they'll stick to it. But really, it's all about communications. Write your equation down, give it to somebody else, or write it in a paper. It must mean that the person reading it, anybody who's reading it, knows exactly what you're saying, so that they will be able to reproduce that information. It's not about really who's right and who's wrong in that respect. Okay, so I hope you got the gist of what I'm saying. So thanks for your attention. Bye bye.